The infinite space spreads out before us like an endless ocean dotted with billions of galaxies. In each of these galaxies there are billions of stars shining like beacons in the night. And around these stars, like the Earth around the Sun, revolve planets. Planets, many of which may have conditions suitable for the origin of life. Given these incredible statistics, what is the probability that life, this miracle, this complex and fragile construct, originated only on Earth? That probability is negligible, practically zero. But then the question arises, echoing in the cosmic void: why are we alone? Where is everyone? This cosmic silence, this lack of obvious traces of extraterrestrial life, gives rise to one of the most fascinating paradoxes of science, the Fermi Paradox. In the summer of 1950, during a casual lunch with colleagues at Los Alamos National Laboratory, physicist Enrico Fermi, pondering extraterrestrial life and the likelihood of interstellar travel, asked a simple but ingenious question: well, where are they all? Fermi's question exposes a fundamental contradiction. On the one hand, the colossal scale of the universe and the laws of probability suggest that extraterrestrial life, including intelligent life, should be extremely widespread, literally teeming in space. On the other hand, we see no trace of it, no radio signals, no spaceships, no artifacts, nothing that would indicate the existence, even of the most primitive form of life, beyond our planet. And that silence is the most puzzling part of the equation. The Fermi paradox consists in the absence of reliable facts of observations of the activity of extraterrestrial technologically advanced civilizations, despite the fact that, according to modern scientific ideas, such civilizations should exist. To understand the magnitude of the paradox, let us look at the Drake equation. Proposed by astronomer Frank Drake in 1961, it attempts to estimate the number of civilizations in our galaxy that could make contact with us. The Drake equation consists of 7 parameters, each of which affects the final estimate. Even if we approach these parameters conservatively, underestimating the values, the probability of the existence of many, perhaps even hundreds of civilizations in our galaxy, the Milky Way, remains statistically high. This paradoxically makes our loneliness, our lack of any contact, even more profound and mysterious. Many hypotheses have been proposed to explain the Fermi paradox. One of the most disturbing is the concept of the Great Filter. It suggests that on the way from simple life to advanced civilization, there is a certain filter, an insurmountable barrier that most life forms cannot overcome. This filter may be in the past, for example, the emergence of life itself, or the development of complex cells. If so, we are unique because we have already overcome this barrier. But if the filter is in the future, it means that humanity is facing a critical event that could destroy, or at least significantly alter, our civilization. It could be anything: an environmental catastrophe, rapid climate change, a devastating global war, a deadly pandemic, or a man-made catastrophe or event that we, because of our limitations, are not even aware of, but which will be fatal. Fortunately, there are less gloomy, more optimistic explanations for the Fermi paradox that do not portend the imminent demise of humanity. For example, the so-called zoo hypothesis, first proposed by John Ball, suggests that incredibly advanced civilizations are deliberately observing us like animals in a zoo, making no attempt at direct contact. Their goal may be to not interfere with our development, viewing Earth and humanity as a kind of unique biological experiment, allowing us, as a young and evolving species, to follow our natural evolutionary path undistorted by outside influences. Perhaps they are waiting for us to reach a certain level of development before introducing themselves. Another, rather pessimistic hypothesis, known as the dark forest, is based on the assumption that the universe is not a friendly and safe place for inter-civilizational communication, but rather a dangerous and unpredictable environment where each civilization is forced to hide its existence for fear of imminent attack or enslavement by other, potentially more advanced and, importantly, aggressive civilizations. In this dark forest of space, any signal detected could be a death sentence. Silence is survival. Another quite possible explanation for the lack of contacts is that advanced civilizations, having reached a certain technological level, eventually switch to completely different, more advanced forms of communication. the principles of which are still completely inaccessible to our understanding. Maybe they communicate using quantum entanglement, space-time warp, or other exotic technologies that we can only guess at. Perhaps for them, sending primitive radio signals into space is an outdated and extremely inefficient method of communication, requiring exorbitant energy expenditures. Our search for extraterrestrial intelligence, primarily the SETI project, is limited by our current technology. We are looking for radio signals, but perhaps civilizations use completely different methods of communication. Also, space is vast and we have only scanned a very small part of it so far. In the foreseeable future, with the continued development of advanced technologies such as radically new, more powerful and sensitive telescopes capable of looking billions of light years into space, as well as the development of sophisticated and self-learning machine learning and artificial intelligence algorithms capable of analyzing enormous amounts of data, our chances of detecting extraterrestrial life could certainly increase dramatically. This will allow us to start looking not only for traditional radio signals, but also for other, more complex and indirect signs of extraterrestrial civilizations, such as giant megastructures artificially created and orbiting stars, or unexplained chemical anomalies in the atmospheres of distant exoplanets indicative of technological activity. The Fermi Paradox is not just a scientific puzzle, it forces us to think about our place in the universe. If we are truly alone, it places a great responsibility on us to preserve life on Earth and to continue our development. If, despite the cosmic silence and lack of clear evidence, other intelligent civilizations do exist in the universe, their possible discovery could give us incredible hope, become a powerful incentive for further development and radically change the trajectory of our civilization. It can serve as an inexhaustible source of inspiration, point to entirely new paths of technological progress that we are not even aware of, and warn us against potentially fatal mistakes that have already been made by other civilizations, thus helping us to avoid self-destruction and preserve our planet. Knowing that we are not alone in this vast and mysterious cosmos can radically change our understanding of ourselves, our humble place in the grandiose universe, and fundamentally rethink our relationship to the world around us, making us more respectful of the fragile life on Earth. Cosmic silence, this oppressive, all-pervading silence of the cosmos, can certainly be frightening, generate an oppressive feeling of universal isolation and even despair in the face of the unknowable. But it should by no means stop us on the difficult path of cognition and exploration. In each of us burns an unquenchable spark of irrepressible curiosity, unquenchable thirst for new knowledge and irrepressible desire for new, unexplored discoveries that await us ahead. It is these unique qualities given to us by nature, which distinguish us from other creatures inhabiting this planet, that make us people capable of challenging the most complex and intricate riddles that the unpredictable universe throws at us with enviable regularity. Who knows, perhaps the long-awaited and exciting answer to Fermi's tantalizing question, which has kept mankind in suspense for many decades, is waiting for us very soon, just around the next corner, and only a small but determined effort, a drop of patience and faith in success are missing for its discovery.